Hi there. It's been a few weeks since I posted my last video, but I wanted to do an intermittent update where I show you a lot of the little cleanup activities I've been doing on my drone and enhancing just the peripherals and making it a little bit more stable and a better build out of the hardware platform. So this video I'm going to walk you through several updates I did, including I added a second GPS. I wanted to get some redundancy there and blend the GPS signals to reduce glitches potentially and take advantage of some capabilities that ArduPilot supports. I 3D modeled in Autodesk Fusion, had to take some time to learn that, but 3D modeled and printed this new lid that will go on the drone and cover the electronics up at the top. I'll show you some of the wiring cleanup that I did. Put some split sleeving around many of the wires to just protect them so that the friction of anywhere that it rubs against the frame will get reduced a little bit and hopefully protect the wires a little bit more effectively. I'll show you the payload area of the drone too. I built that out. I replaced the standard 12mm carbon fiber tubes that come with the RJX hobby frame that I bought. Got some longer ones from Amazon and I put those in so that I can mount some more bigger payloads essentially. So you'll see in this video I put a Gremsy dampening plate in there, and that's in preparation for the gimbal and camera that I'll show you in the next video when I put all that together. But because I had the drone apart and was rerunning things, it made the most sense to install the dampening plate and HDMI Hyper quick release now. So here's a picture of what that HDMI Hyper quick release looks like. I'll give you a close-up of where those are installed in the drone, but then we'll do a deep dive in the next video when I get that put together. Couple other things I did too. If you remember in an earlier video, I had a TFMini-S LiDAR that I installed and it was just kind of hanging out on the top of the frame. Well, I moved it down lower in the payload area where I put these new ABS plastic sheets so that it gets a clearer view of the ground. And I found this device from Matek. It's an L431 peripheral. It's an ArduPilot peripheral, which will take a serial device such as the TFMini and convert it to a drone CAN device. So that allowed me to install a nice drone CAN or a CAN wire from the Autopilot down to my payload area, and then I got a CAN splitter there that will allow me to connect multiple devices there for some future build out. Let's see, what else did I do? I think that's about it. I mainly did a bunch of cleanup and just trying to harden the hardware, making it a little bit more laid out, clean, and trying to tie things down so things aren't vibrating. And so I'll walk you through it all right now and show you all the little changes that I did. And then that'll be preparation for the next video where I show you the Gremsy gimbal that I got. This will be coming up in a future video where I'll show you how I'm going to install this on the drone and mount a Sony camera and so forth. So come on over to the drone. I'll get a close-up and start walking you through all the changes I did, and hopefully if you're following along at home, it'll help you get caught up with some of the things that I've been building and changing on the drone. Alright, over here at the drone, I think the best way to walk you through the updates are just to take you from top to bottom. Right, everything's installed, so I won't be putting them in and showing you how I connected everything in this video. But hopefully this video gives a good enough overview where you can replicate and follow along. So the first update I made is I added a second Here4 GPS up to the front of the drone. So this one is connected to the CAN 2 bus, and so I got a primary GPS back here in the back that's connected to CAN 1. I added a second one to CAN 2. I am not blending these GPSs. It sounded like that's no longer needed based on a forum post I made on the ArduPilot discussion boards. So it's purely for redundancy at this point, and I think it will give me a second compass as well. The other thing I did was in some of the wiring, I don't know if you can see it, I'll try and get a close-up. I added some of this split sleeving, okay, and I'm just adjusting the camera here. So for example, on this cable here that went to my now you can't really see it from that view, but it went to this little I2C display, right? I just took some of the cabling inside while it was all apart, and I applied the split sleeving over it so that basically the bare wires aren't well, they're insulated, but they're not just floating around in here. They also have a second layer of protection with this split sleeving. So I was able to get some of the wires to do that, not all of them, but that was an improvement I made to some of the wiring. And I'll show you where I ran outside the drone frame as well. For example, on the side down here, not sure if you can see it yet. Now I'll show you when I get a side shot. Anything coming outside the drone, I definitely encapsulated in that split sleeving. Another item that I did, let me back up to show you as I install this, was I made a new lid. And my problem with the lid that I had, this is the stock lid that came with the RJX Hobby frame. Okay, it was not deep enough to cover the electronics that I had coming out of the top of it. Okay, and so what I did was took some time, learned Autodesk Fusion, or just enough to basically build this. I wouldn't say I learned it yet. And I 3D printed a new lid. Okay, so I made a very deep lid that covers the whole thing and will mount right to the frame itself. Okay, I added little slots around each edge. This isn't designed to be a waterproof drone or out in the elements or anything, so I figured these slots would promote some airflow, and I also added some slots to the top to allow these fans to suck in some air for the Raspberry Pi and the Herelink. In the front, so I had to notch a little piece out to get it to fit with where I mounted that GPS. In hindsight, I would have taken this GPS and flipped it around so it's actually going away from the drone, giving me a little bit more clearance from these electronics, but I didn't do that. Maybe I'll do that in the future. I don't know. And I also have this bubble level that I bought from Amazon that I just stuck on with some Velcro, and that helps me when I am calibrating it, right? So I can see if the drone's truly level, and you can see I also have another bubble level on the side over here and in the front. So I got a couple of levels on here just to make sure. It allows me to put some shims underneath the landing gear to kind of move it so that it is actually level when I calibrate. So this lid also has some little attachments that I designed onto it as well, and that's where it screws to the frame. It just uses some M3 screws. I can't remember how long they were, 20 millimeters or something maybe. And to install it, right, it just slides on over. And we tuck the wires in, and then we'll screw to the top. I also have these little notches on the sides and the back, these little semicircle pieces. Not sure if you can see it, for example, like up here, my USB cable to the flight controller is coming out of the little semicircle notch there. Okay, so that's what that looks like. Also, I started to wire up a couple other components for the USB peripherals to the Raspberry Pi. So I'll try and get you a view of that. Lift this up a little bit. So there's not a ton to see with this because the wires basically just run through the frame. But you can see right here, there's a USB cable connected to the USB 3 port in the Raspberry Pi, and then I got another one attached to the USB 2 port. This is a USB-C cable. This is a USB micro, micro USB cable. And they both go to the front of the drone, which I'll show you in a minute. The USB-C cable is actually connected to an Intel RealSense depth camera. I don't have it working yet. I got it mounted, but I gotta figure out the software that I want to use to be able to pull in the video stream. The Raspberry Pi also has an HDMI cable going to the HDMI 2 port on the Herelink, so I can get the video feed from whatever I output to the HDMI port on the Raspberry Pi, and then set that to the secondary video feed on the Herelink. My thought is I'm going to install an X server on that Raspberry Pi, which will give me kind of a graphical environment, and I'm hoping that I can run a program that runs in the background to pipe and enrich and enhance the video feed and send that to the console HDMI port. So that's what I got to experiment with in a future video, but if I could do that, I can write my own custom programs that process the imagery from that camera and pipe it back to the ground station and see it live. The other HDMI cable that wasn't connected previously is connected to HDMI 1 on the Herelink controller. That runs through the frame of the drone, and it goes to the bottom down here. I'll show you when I get a close-up and I start working through this area to explain it to you. But it goes down here and ultimately under the drone where the Gremsy gimbal is getting mounted. Okay, so I got a T7 gimbal in a future video that I'm going to install and use to connect a nice camera to. So that's run. And then the other wiring that's new that you're not going to see in this video, but to the second serial port, UART2, or I believe telemetry 2 on the core carrier board, I ran a serial cable from there down to the bottom down here, right? Like the same spot where the HDMI cable goes, so that I get a serial connection to the Gremsy HDMI Hyper quick release. And I found these nice cables from 3DR. If you go online, you can actually buy some nice long cables that have the JST-GH 6-pin connectors on them. And so I did that, and then I basically just modified this cable some. I had to swap the TX and RX lines by pulling the pins out of the connector and making it so that the serial port talks properly to the HDMI quick release. So this HDMI Hyper quick release, I'll cover more in the future video when I get to the Gremsy gimbal, but this is designed to work with the Gremsy gimbal itself. The gimbal attaches into the bottom, and it gives you a nice button here where you can quickly attach or detach your gimbal, and then all the connection points are in it for your various components. Okay, so power. I did also run another cable from the BEC, sending I'm sorry, it's not even from the BEC, from the battery, from one of my speed controller connections where I had those multiplexed octopus cables that you see in a previous video. I'm sending the full battery voltage down to this. I got a 12S battery. This takes up to 52 volts, so it works, and it does the appropriate voltage reduction inside the circuitry of the gimbal as well. So there's a power cable run to the bottom. There is also, this is the serial connection here. So from the core carrier board, I'm going to the serial connection. And then lastly, there's an HDMI connection here as well that goes to the Herelink. So all of this is mounted underneath the drone, kind of right in the middle, to a dampening plate that I'll show you in a minute. I think that's about everything that I've hooked up kind of up here and on the internals. I also, as I work through all the wires, tried to cable manage everything a little bit better. So basically just some more wire ties, trying to tighten down the wires a little bit more. I was careful though not to pinch them too much. I didn't want to break the wire, but I didn't want things shaking around as much. So all my power cables and data cables and stuff are in here. I tried to separate the data cables, CAN cables and so forth from the power cables as much as possible to reduce interference. It's hard. It's a tight space in there, so it surely wasn't perfect, but that was a goal of mine as well. I also put some labels on some of these things, right? It's just so I can remember what these cables are. You can see that, you know, this says camera HDMI on this label here. This little JR connector says strobe, so that's going to go to the top white strobe light that I have that I can mount to the frame. So it helps me when I disassemble this thing of putting it back together. All right, well, let me reset the camera a bit so that I can get you a better shot at the bottom, and I will start to talk you through what changed in the whole payload area down here. There's been significant changes there as well, or enhancements. So I'll be back in a second. Okay, so this is the back of the drone here. You can see my battery and tray and mount and everything. And what I wanted to show you in this is these trays and mounts that I created. So I had to get longer carbon fiber tubes. So on Amazon, I bought these 12mm by 330mm carbon fiber tubes, which is just a little bit longer than what came with the drone. And they slide right into the same mounting points that the old tube slid into. But what I did here was, off of Amazon, you can buy ABS plastic sheets. So I bought an 8x8 sheet, and I cut that thing down into, I think, a 2-inch strip and a 3-inch strip, and this is what was left over then, another 3-inch strip, I believe. So what I did then, fine, there's one more component you need to see. So I got these pipe clamps. I think I found these off of eBay, but they were just 12mm pipe clamps, okay? And so they clamp really nicely to a 12mm tube. They got a screw and a lock nut on each side, and there's enough space to mount about 1/8 of an inch plastic sheet to it. So the way this worked is I took these and drilled some holes and screwed them to my plastic sheets, and there was 4 on each one to give it stability. And then, if I get a close-up here, I just slid them onto, so I got the plastic sheet mounted to the pipe clamp, slid that onto the tube and tightened it all down, so I got a nice little payload area in the back, and I also put one in the front, which I'll spin the drone around in a second and show you what that looks like. And on the back payload area here, let me see if I can get an undershot of stuff. I moved a couple of the sensors, specifically the TFMini LiDAR and the HereFlow. And what was kind of cool on this is, well, first of all, I needed a longer drone CAN cable, or CAN bus cable. So from 3DXR, I believe this is the company in the UK, not 3DR, the one that I was just showing the other wire from. They make these nice long drone CAN cables. They're insulated. They're well worth the money. I stink at making my own cables and trying to get these pins crimped right. So for me, it was well worth less frustration of having a cable that worked out of the box, and I can run, you know, from all the way up in the top from the core carrier board outside the drone down to my payload plates down here. So I did that, and I ran that into an Matek L431 AP peripheral board, and I don't know if I can get a good view of it. I'll show an undershot in a second here, but I'll explain it first. So there's this peripheral board here that CAN connection goes into it, and then it also has a CAN out connection. And so into that peripheral board is the CAN connection from the core carrier board. And then on the other side, it has a serial port that I connected the TFMini LiDAR to. And I put it back here and out of the way a little bit more. I moved it to have a little bit more of an open view of the ground, right? And it seems to be working well so far. The other CAN connection coming out of this then goes to the HereFlow optical flow sensor. And since the prior video as well, I did disable the rangefinder on that optical flow sensor. It was flaky and not working well. It's recommended in the docs to disable it anyway. So that thing is shut off, and I only have the one downward facing LiDAR now. So that's kind of what's at the back here. And then let me see see if I can back this out a little bit. Right here, not sure if you can see it, all of the cabling that's coming out of the kind of top section up there, I put in either 1/2 inch or 3/4 inch split sleeving. So I have the USB cables, an HDMI cable, the telemetry cable, the power cable, everything going to that Gremsy HDMI Hyper quick release is all in that split sleeving now, just to protect it a little bit since it's outside the drone. And not sure if you saw this in the prior video as well, all of my strobe lights that are going to out to the motors, right? I got the red and green strobe lights. All of that is covered in split sleeving and just zip tied to the arms right now. So let me see if I can get an undershot of the drone here, and I'll talk you through what that peripheral board looks like. I'll show you the dampening plate that the Gremsy HDMI Hyper quick release connects to, and then I'll flip the thing around and show you the front payload area as well. So let me pause and I'll be right back. Okay, under the drone, you can see a little bit better close-up of how I got that optical flow sensor, that Matek board, and the LiDAR all configured. So optical sensor is right here, Matek board is there, LiDAR is there. Okay, so kind of a cool board. You give it an ArduPilot peripheral firmware, you can go into that thing like it's a CAN device and configure its parameters, and basically I told it that it's got a LiDAR connected to its serial port. And it's very similar to configuring ArduPilot settings. It's like a stripped down version, it looks like, of the same parameter set that's actually in your typical flight controller. So let's try and zoom up into here. In the middle of those of the drone on the underside, attached to the carbon fiber tubes that hold the payload, is a Gremsy dampening plate. So I'm preparing for the next video where I actually mount the gimbal and camera. It's taken me a while to research all that, but I had to have everything apart to get this all kind of rebuilt. And while I was doing that, I wanted to mount the dampening plate. The dampening plate is super nice. It's an expensive dampening plate. I think it was $200 or $250 for this thing I ordered from Gremsy, but it has all the rubber mounts. It's very high quality. And it clamps to those carbon fiber tubes very well. There is a screw and kind of a connection point there, and it attaches, and it's very stable. Connects very nicely, and it's designed to have the HDMI Hyper quick release mount to it as well. And you can see in the back here, that's where my power cable goes into it. And runs back to the top of the drone. What else? So kind of I'll get you a side shot there. I'll flip it around and we'll be able to see some of these other pieces on the cables going into the Gremsy gimbal as well. But from an underside view, that's what it looks like, right? So highly recommend this Gremsy setup so far. I've been really impressed with the build quality. It doesn't look like they cheap out at all on the quality of the parts that they use. Okay, so that's what the bottom looks like. Let me flip it around and give you a front view of the front payload area real quick, and then I'll show you a couple other things that I did as well. Okay, from the front of the drone, I just flip the thing around for the camera here. Again, I've got another payload. This, instead of the 3-inch sheet, which I used in the back, I used the 2-inch one in the front. I didn't want as much sticking out in case it covered the camera that I'm going to mount to the gimbal at some point. And in here, I've got a USB micro A, or USB micro cable, micro USB cable, and then the USB-C cable is going to this Intel D435 depth camera. Okay, I don't have them working yet. but it'll be in a future video, more stuff to experiment with and figure out. The thought with the micro USB cable is I have this FLIR pure thermal camera that I bought from Group Kits. It's the USB version, and it's a cheap thermal camera. It is not designed for professional thermography or anything. But my thought was I may mount it somewhere up here just to play with it and experiment with it, and that micro HDMI cable or micro USB cable is what will connect to it. So that's that component and kind of the rationale around some of that stuff. Let's see, what else can we show you? Right, the whole drone from the front. I'll try and get an angle here. Right, that's what it looks like. It's a good sized drone. It's big. Should be able to carry plenty of capacity. What else do we have going on here? I think that's about it for the hardware updates I did. I wanted to show you those peripheral updates. Let me show you a couple other modifications I did for my field setup though. So I'm going to pause that. I'm going to move this drone out of the way, and then I'll show you some of the components that I'm using in the field for communication. Now, when I'm out in the field, I discovered, you know, if I'm in a remote location with no Wi-Fi and so forth, I had some challenges making everything connect. So when I'm in the field, I bring my laptop, I can run Mission Planner, got the Herelink controller, and what I ended up buying was a travel router. So this is the TP-Link WR1502, and what's really nice about it is you set it up, you have it connect to a Wi-Fi network, and what I did was I set it up to connect to my phone's hotspot, and then it will create a Wi-Fi network, kind of an internal one, like you might have at home, and it will also broadcast on the 2.4 and 5 gigahertz frequencies. So what I did was I set up my laptop to be able to talk to the Wi-Fi network that I created on this, and I set up the Herelink to be able to connect to it as well, and that allows all of this equipment to communicate to each other in the field then wirelessly. And it was important, I had to get a travel router that supported the 5 gigahertz Wi-Fi frequency, because if you remember, the Herelink controller needs a 5 gigahertz Wi-Fi point to connect to. It does not connect on 2.4 gigahertz because I believe that was used for the telemetry to the actual hexacopter. Also, just to complete it, showing you, here's the Here4 base GPS cable as well, right? So if you looked at a prior video, you'll see where I set this all up. This Here4 base actually connects to, you need a coax cable that's going to go to a GPS receiver that I got mounted to a tripod. You can see all that in a future video, but that allows me to feed ground station GPS information into Mission Planner, which then it can send to the hexacopter as GPS correction data as well for the RTK capabilities. I have yet to prove out if it works well. I still am trying to learn there about how that all works. It seems to get an RTK fix, but I don't know how precise it actually is yet. I'm still trying to find a good way to measure that. So the other thing with this travel router is I bought a really big battery, portable, like, you know, phone charger battery. Just something off Amazon, 50 amp hours? Yeah, 50,000 milliamps. So it's a big battery. You got to be careful if you have something like this. I don't believe they let you bring this big of a battery on airplanes, so you may want to buy a smaller one if you're going to be traveling with it as well. But this gives me plenty of power. This travel router then just plugs right into it and powers itself up. So I got a pretty long battery life for my Wi-Fi router to be running in the field. Okay, and this battery is nice. I can use it for a lot of other things, charging my phone, running other devices off of it. It's a pretty nice beefy battery, so I'm hoping it's high quality and lasts for a couple of years and doesn't burn out after a couple months, but we'll see. In terms of other ground station equipment that I got as well, I did not know that there is a Herelink QGroundControl app that is published out there on GitHub that looks to be maintained, right? So I've been wanting to get updates from my QGroundControl app, and it never seems like they come from CubePilot or from the updates that this thing gets, but there is an app published. So I downloaded the APK file for that Herelink QGroundControl, copied it to the micro SD card, and installed it as an app, right? And so what you get is a really recent version of QGroundControl running on your Herelink controller. It was updated as of a month or two ago, I believe, with the download that I saw. And this had much better integration with the Gremsy gimbal. It seemed to have some of the later features where I can tap on the screen and drag it to move the gimbal around and so forth. And so that's why I was searching and stumbled upon this, and it was a great find. They did change how the telemetry shows. I'm not wild on the new interface. I'm getting used to it, but it works. And yeah, I mean, this is, I don't know if you can read that down there, version 4.4.2.1, the Herelink 64-bit version. So again, it's a little tricky to install if you're not super savvy with computers. I ended up following the instructions for the CE or SCIE camera app, right? They have a video on YouTube that shows you how to install their custom app, and ultimately at the end of the day it was pretty easy to follow along with. Instead of getting the CE APK file, I got the Herelink QGroundControl APK file, downloaded it, copied it, and went through the same install procedure, and it shows up here. So pretty good stuff. And then I added it to the home screen, so it's easy to access there. So I'm finding myself using that one rather than the stock QGroundControl that came with the Herelink controller. I mean, to install those apps, you basically plug the USB connection into your computer, and it will show up down here, and you tell it that you want the USB connection to be in file transfer mode. When you do that from your computer, if you're running Windows at least, you can see it on Windows Explorer. And you find your file system and you copy the APK file to it. And then there's a trick in the CE video where you got to put your device into developer mode. But once you do that, you can essentially go to your file explorer through the apps in here and install that APK file, right? So see if I can find that real quick. So in your Android settings, right, you go down and there is a storage icon here. Click on that. You'll see your internal shared storage. You click on that. And then there is an Explore option at the bottom that you can click on, and you'll see all your files, right? And so the QGroundControl Herelink that I copied to the file system here is right there. And all you do is you tap it, and it says, hey, do you want to install this app? And there's an install button at the bottom. So pretty easy to do. All right, so that I think is a quick summary of the hardware and peripheral updates that I made. Let me show you a couple things in Mission Planner real quick, and then I will wrap this video up. I'll be right back in a second. The last part of this video, I'm going to walk you through some of the software side of things and the resources that I have on the GitHub page for everything that I just showed you. So if you go to the video link or video description, there's a link to the GitHub page for this project, for this Hexacopter build project. And if you scroll down again, I've shown this in other videos, but there's a link to get to the wiki. And if you scroll down in here, there is a couple things of interest. There's a bill of materials page. If you're looking for anything that I've purchased for this drone, it's linked in here. Okay, so for example, I talked about the 12mm carbon fiber tubes for the gimbal and camera payload area, right? It's down here, electronics, gimbal and camera section, right? And there's 4 pieces, 12mm carbon fiber tube. Amazon, $22 to buy that set of 2 tubes, or 4 tubes actually. All the electronics, wires, components, sensors, it's all electronics onboard drone, right? Starting from the Raspberry Pi. There's that Intel RealSense camera. You got your Herelink in here, core carrier board, cube orange, all that fun stuff, right? So down at the bottom here, there's a link to that Matek or Matek. I don't know how to pronounce it. If I'm pronouncing it wrong, please let me know in the comments. But I've been saying Matek, but that Matek AP Perif can node L431 board. You can buy it off Amazon for $21. Okay. So below the bill of materials, when I go back to that main wiki index page, is the step-by-step build process. So we are on video 15 here, and it's where I'm walking through all the peripheral updates. In here, I got a link to the YouTube video, but I also have the build notes, and it's basically highlighted or bullets of the different highlights that I did to the drone in this video. Added a second Here4 GPS. Remember that top lid that I printed, the new lid with the deeper lid and kind of the cutouts and airflow holes and everything. Well, the STL file, so you can 3D print your own, and the Autodesk Fusion for the 3D lid top are in here. So if you click on that, located here, I'll open it in a new tab. It's just going to take you to another area of this same GitHub project. You see we're in the 3D print files area, drone top lid subfolder, and there's the Fusion 3D file and the STL. So you can download those and edit and change it yourself, or just print the STL file as is. Okay. A couple more bullets in here that I already talked through in the video. You know, new 12mm payload tubes, longer 6-pin cable from 3DR for the serial connection to the gimbal, cut down an 8x8 sheet of plastic. The link to that plastic sheet is in the bill of materials as well. USB cables getting run, Intel RealSense camera, HereFlow module and TFMini were mounted to the back payload sheet. Gremsy dampening plate and HDMI Hyper quick release were mounted. The next video I'm going to create, though, is going to have way more detail on the whole camera setup. Disabled the HereFlow rangefinder, but I left the optical components active. So it's important to note that I moved the TFMini-S from rangefind 2 to rangefind 1, right? So in the setup, in the notes down here, there's the ArduPilot configuration. If you open that, it's pretty much every setting that I've changed in ArduPilot. And if I search for rangefind, well, I left it active in here in case you want to have them both, but the TFMini-S rangefind 2, I actually changed all the 2s to a 1, and I did not set the HereFlow rangefinder settings. Okay, here's your settings though if you want to use that Matek AP Perif board to convert your TFMini-S to a drone CAN device. So instead of doing these settings with the serial port and so forth, you're setting your rangefinder 2 type to 24, which will be a drone CAN device, and set the minimum and maximum clearances as you did before. Okay. We back up So in your AP per HIF board, right, to get that thing to work the way I set it up with my TF Mini, you need to follow these instructions that I'm highlighting here. So you need to get the latest firmware to enable seeing the rangefinder parameters. And you need to download that firmware from this link here. So if I open this up, ArduPilot publishes their AP per HIF firmware for that Matek L431 to be able to add the rangefinder parameters. So essentially download the bin file, and then you're going to go in Mission Planner, go to Setup, Optional Hardware, Drone CAN. You're going to connect to your CAN interface. You're going to press Update, which will let you select a new firmware file. You're going to select the bin file you downloaded, and after you update to the new firmware, you'll set the menu button or select the menu button to open the parameters, and you can set these rangefinder values in there. I'll show you that in a second. Reading in the forums, they said don't have two rangefinders pointed in the same direction. Things will likely get confused by the different signals bouncing back and forth. So that's another reason why I disabled the HereFlow rangefinder. And another thing I didn't show, and it's just a bunch of work, I configured the position X, Y, and Z parameters for both of my GPSs, the rangefinder and the HereFlow. So what you want to do is set those positions as offsets in meters, I believe, from the middle of your CubePilot. And so I put a link here, ArduPilot Sensor Position Offset Compensation Wiki. If you open that up, you're going to get to a page that will talk you through all the different things to record, right? And how to measure your X, Y, and Z values. Okay. Let's talk about that Matek board real quick. If I open that up, this is what it looks like. Right, it's pretty simple. It's got the two CAN ports, like I said, and you can daisy chain them. So I have one CAN port coming from my core carrier board from the CAN interface there. And the second one, I'm coming back out of it and connecting my HereFlow optical sensor to. And then on the other side, this is where the TF Mini connects to. It's just the same serial connection that you would normally connect it to your 6-pin telemetry or serial port on the core carrier board, except it plugs straight up into this board here. Okay, and what it does is a little microprocessor on it, microcontroller that converts the serial data to drone CAN messages. So pretty neat stuff. To see that, if I pop open Mission Planner, for example, I'm connected to the drone. If I go to my setup page, and if I go under optional hardware, you'll see the drone CAN tab here. Connect that or click that, and you're going to then pick the appropriate CAN bus that you connected that device to. In my case, I think I did it to CAN 1. Let's check. So I'm going to pick Mavlink CAN 1, and I'm going to say connect. And wrong one. Disconnect. It's connected to CAN 2 in my case. So CAN 2, you can see there's a device out here, Org ArduPilot Matek, that will show up. And those menu options I was talking about to update the firmware, you would do menu, update. Do you want to search the internet for an update? No, I don't. It will then prompt you for an APJ file that you downloaded. Or actually, I'm sorry, for a bin file. So this is where I would have downloaded the bin file from that GitHub page and selected it. It would then write the new firmware to this rangefinder or to the Matek device. And after it restarts, from the menu, you can go to parameters. And you'll see the different parameters that you can configure in here to make it work with the rangefinder. Right? I changed the rangefinder 1 type to 20. And that is what I would normally put into the flight controller settings if it was the TFMini LiDAR. And I also set the baud rate, and I have it connected to port 2, the second telemetry port, or second serial port on that Matek device. So you kind of tell it in these settings here how it can communicate with that TFMini device. And then from there, it just forwards the messages out as drone can, apparently. So kind of neat. I'm nowhere near, by no means an expert on this thing. I found it, played with it. It's kind of neat. More that I need to learn about it, though. Okay. One more thing I want to show is that update that I did to the HereFlow. Or, I'm sorry, not to the HereFlow. The Herelink controller, installing that custom QGroundControl build. So if you go back to my Wiki page, there is a Herelink initial config page in here in video 3, and I updated the page to have a link to the QGroundControl Herelink releases. So if I open this, you can see the releases that they're creating from CubePilot. And here's an APK file you can download. And then from there, you would install it on your Herelink. I mentioned I also looked at a CE or SCIE video that showed me how to watch it. So I have the Herelink how to install a custom app video that will take you to their video that walks you through all the steps for installing a custom app, right? In this case, it is their CE QGroundControl app, but it's the same steps. You just pick a different binary file or APK file and install it, right? So this will help you install that as well. So pretty cool stuff. I think that catches up the video series with everything I've done to the drone. I'm still tuning and playing with it. I'm trying to get better at understanding really what's happening under the hood with notch filters and the PID tuning and so forth. The drone flies great. I don't know if you saw a video that I posted before. It hovers and flies really well. I think there's still more work to be done, and I can always get better at understanding it more. And so I'm going to be working on the gimbal and camera mounts, and then also just continuing to learn more about tuning. There really is a deep set of parameters that you can change in ArduPilot. It's just, there's a lot to learn, a lot to understand, and it's by no means easy. So I'll wrap this video here, but hopefully you found a lot of these updates useful. Hopefully the next couple of weeks I get the gimbal and camera video out there and show you how this all comes together, and that'll complete the build. So I'm pretty excited to be able to get all of that in place. All right, until next time, thanks for watching. All right, here comes test number 3 of just a very simple hover in loiter mode using the GPS to keep it still. Arm the motors. It's hovering. Try to roll right, or roll left, pitch forward, pitch back, yaw left, yaw right, You can see hands are off the controller. This is just it stabilizing itself, holding its own position. So we're going to do this for about a minute or so, and then I'm going to check the temperature of the motors, and we'll go run some analysis on the vibration in the frame, tune it up a little more. It's pretty windy out today too. I don't know if you can see the top of the trees. This thing's holding itself. The wind's catching it a little bit there. Let's try the auto land. There it goes, it just landed itself.